Okay, today, how to convert a variable into stationary, that we shall be checking today. How to convert a variable into stationary, that we shall be checking today. And to convert the variable, one of the ways is to convert a variable into stationary is first difference. So you can see from here, one of the ways is to convert a variable into stationary is first difference. So that is the one of the way to convert a variable into stationary. And in our case, we have a variable y, which is non-stationary. But when we convert it into first difference, it becomes stationary. Okay, I'm telling again. In our case, we have a variable called y, which is non-stationary. But when we convert this y into first difference, it becomes stationary. Then comes up, and when the variable becomes stationary, we can use this stationary variable in time series model, such as var, VSM, Granger, causality, test, etc. That means when the variable becomes stationary, we can use the variable into various time series model, such as var, VCM, and Granger causality, etc., etc., etc. Because time series model normally needs stationary data or stationary variable. That means the variable must be stationary. Only then we can use it in the time series model. And here we shall be appointing Correlogram and Q statistics to do all these tasks. So here actually we shall be using Correlogram and Q statistics to check all these things, whether a variable has become stationary or not. And we set the hypothesis. What is our null hypothesis? Variable is stationary. That is desirable. We are looking for. And what is alternative hypothesis? Variable is not stationary. That is alternative hypothesis. And what is the guideline? The guideline is when the p-value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. But when the p-value or the probability value is less than 5%, we reject null hypothesis and accept alternative hypothesis. What is our alternative hypothesis? Variable is not stationary. So we shall be now applying this hypothesis now using EVIEWS. Okay, suppose we have a data variable which is y. It is from 1960 to 1995. It is the y variable. So what I am doing, I am opening this variable I'm opening the variables. Sorry, I've done a mistake. I'm opening here. Open, not here. Let's double checks. Opening these variables. Opening as a, just a minute. Opening the variables. So text files are here. Just 1 minute. I'm opening the variables to show you. Wait. Okay. Just 1 minute. Not this one. Yes. This is our variable, which is y, as I said. The data, you can see the y, and it is from 1960 to 1995, right? So this is our model. This is our variable y from 1960 to 1995. You can see. Okay, and this one is a time series data, and our task is to convert this variable into stationary. That is our task. Okay, so what is to be done to do it? Okay, first we see about this variable. Just I go to graph. You see, I go to view, I go to graph, then I click on it, and this is basic graph. Line and symbols all are here, right? So then I press OK. You see the y variable, you can see from here, the y variable that we have is gradually going up, right? You can see it is going up, meaning that our variable is not stationary. It has an upward trend. So our task is to make it stationary. That we want to do. And when this y will become stationary, then we can use the variable in various time series model, such as I said, var, VCM, Granger causality test. Okay, so we can see from here that our variable y has a upward trend. So but we want to check it further by statistics, whether our y is a stationary or not stationary. How to check? Okay, we want to check it. How to check it? What we shall do? We shall be doing some more procedures, examples. I'm doing here. Just a minute. I go to quick. Then I choose the series statistics. Then I choose the Correlogram, because last time I said that I shall be using Correlogram and Q statistics to check whether a particular variable is stationary or not. So I click on the Correlogram, and what is the series name? The variable name that we are using, that is y. So I write y here, then I press OK. Okay, here there is something, Correlogram of at level, first difference and second difference. So suppose I choose at level. What does mean by label? Label means the initial data. So that I choose now, the data we have. Okay, and lakhs is how much? Suppose here 16 lakhs. 16 lakhs I have chosen. Okay, and if it happens, then I press OK. This is the outcome of Correlogram. You can see from here. Right? I make it big. Right? So you see, it is the outcome of Correlogram. And you see, these are the lakhs: lakh 1, lakh 2, lakh 3, lakh 4, lakh 5. So we have chosen 16 lakhs, right? 1 to 16. So these are 16, and this one is the autocorrelations, right? And these are the variables of autocorrelations. Sorry, not variables. These are the autocorrelation coefficient, which are very big. You can see, which are big, meaning that there exist some autocorrelations. And this one actually is this one. You can say this one, and this one is the same thing. Suppose I say this one means this one means this one means this one, and you can see it is gradually going down, and here also gradually going down, right? So when it goes down, meaning that when it gradually goes down, meaning that probably the data is non-stationary, because it is gradually going down, right? And the variables are, and here the autocorrelation, the figures are big. The figures are not zero, they are big. It means that we can suspect that our variable, which is y, is not stationary. Okay. But still we can check using Q statistics. You see from here, Q statistics, right? The Q statistics and corresponding p-value. Here the p-value all are zero. All are zero means we can reject the null hypothesis and accept alternative hypothesis. What is our null hypothesis? Null hypothesis is the variable is stationary. And what is our alternative hypothesis? Variable is not stationary. So here all the p-value are zero, meaning that we can reject null hypothesis, meaning that we accept alternative hypothesis. It means that the variable is not stationary. That is, we can make it confirm. So we can make it confirm by Q statistics and corresponding probability value that our variable, which is y, is not stationary. But here, what is our task? We want to make it stationary. But the question is that how to make a variable stationary? we have to convert the variable into first difference. That means our y variable, we should convert it into first difference. And probably if I convert it into first difference, probably our y variable will become stationary. Okay, now I check how to do that job. As before, I go to quick, then I put series statistics and I choose that Correlogram. As before, I put our variable, which is y. I put it already. Then I press OK. Okay, last time we did it at level. Last time we checked at level, the y variable at level. Last time we checked, we did, but the variable became non-stationary. Now what I do, I convert the variable into first difference. Then I check what happens. You see, I click on the first difference. I click on the first difference and the number of lakhs remain unchanged, 16. Okay. Then I see what happens. And I okay. Now you see the Correlogram had changed. This one is called Correlogram, had changed completely. You see there are 16 lakhs and all the autocorrelation function has become very small. Last time they were very big. Now this time become very small. That means probably probably the variable after the first difference has become stationary, because all the values here have become very small, meaning that there is almost no autocorrelation. There is almost no autocorrelations. And this thing you can see here also. You check this thing, this figure and this figure is the same, no difference, right? Okay, now I check the Q statistics. Q statistics can make it confirm whether the first difference of y, you can see the first difference, dy, the Correlogram of dy. What does mean by dy? The first difference of y. That means the variable we are using now actually has become first difference of y. And from the Q statistics, you can see the Q statistics and corresponding p-value. You see all the p-values of 16 lakhs, right? You can see 16 lakhs and the corresponding probability all have become zero, all have become very big. But last time they were very small, they were zero. But now you can see all are very big, at least more than 5%. You see this one is how much? 13%. This one 31%. This one 9.6%. This one 33.5%. This one is 39.7%. All are more than 5%. And if the p-value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. The question is that what is our null hypothesis? The null hypothesis is the variable is stationary. That is our null hypothesis. And here we cannot reject null hypothesis because all p-value are more than 5%. So meaning that the first difference of y has become stationary. Now this first difference of y variable can be used in time series model such as PAR, VSM, Granger causality test, etc., etc., etc. Okay. So yes, we have converted variable into first difference here. Okay, suppose if we plot if we plot the first difference variable, then how the thing will be looking like, that we can check also. So the first difference variable, suppose something like this, how to do it. The first difference, okay, so sorry, come here mistakenly. Okay, the first difference variable looks like what? Looks like okay, I'm sorry, I make it big, I take it small, I take it out of work file. Okay, so it is the y. So first difference of y actually looking like this. I go to file, I go to file, then what I do, I'm sorry, first difference I make it, okay, I open it, not this one, sorry, okay, I plot it, the first difference of y is coming, okay, I go to view, not this one, not here. First difference of y should be open here. First difference of y series, not here. Graph. Okay, okay, so this one is the first I draw the y variable at level. You see it is at level, right? You see the y value at level, right? It is not first difference yet. Okay, now if the y becomes first difference, then how it looks like, that we can also check using just do it, first difference of y, okay, options, what is the icons, first difference, that I've done it, I'm looking into it, okay, sorry, I take it down, sorry, it is disturbing me, okay, let's make it big and make it small, what's the file, yes, it's my file, right, the first difference of y, okay, what I do, suppose I create a variable here, that I create a variable object, right, and put it as a so dy, what dy, suppose the first difference of y, right? I do this variable first difference of y dy. I create the variable. So I create a variable. So I create the series which is dy difference of y. See the variable is here, right? Dy. And what does mean by dy? Then make a program here. You can see we can make a program. What does mean by dy? Dy means actually first difference of y. You can see from here, dy means the first difference of y. We can write a program here, right? Then I enter. Okay, now you can see our dy has become the first difference of y. Okay, now what I do, I plot this variable. I plot this dy variable. So what I do, I go to view. I go to view. View will not come up. I go to file, not file. I go to dy. Go to just a minute. I go to dy. I go to just a minute. What is graph? Yes, I go to quick. First I select dy, then I go to quick, then I go to as I said quick, then I choose the graph here, right? It is y already given y, right? Then I press OK, and all things come basic graph lines and book. Then I press OK. You see it is our new variable first difference of y. You see that it has become like this. What does mean by like this? It means the variable is stationary because the variable has no trend. So our y variable has converted to stationary variable, and which is this one, right? And the thing is that last time y was our variable, now dy will be our new variable. Okay, what I do, I open both. You see, last time we had y variable, now the y variable has converted to dy, which is first difference of y. And now we shall be using this dy variable into time series model such as VAR, BCM, and etc. So that means we shall not be using y variable anymore. We shall be using dy variable from now on. So you can see the variable is from 960 to 1995. Thank you very much for being here. So here are the terms of uses, right?